know that the world is changing, and what is happening is in the industry is that, especially from the radiology perspective, availability of radiologists are becoming more and more difficult, and at the same time the productivity of each radiologist also is very, very less. So in this regard, a lot of technological advancements are also happening using the AI and ML kind of scenarios, which will enable, though it cannot replace the current radiologists. There is, the world is moving, and in this case we are inviting Mr. Rohit Bhargava, who is a pioneer in cancer detection using the image technologies. I would like to welcome Mr. Rohit for this discussion. Thank you for coming and talking to us, Mr. Rohit.
Thank you for having me.
Yeah, good morning, sir. How are you doing?
Good, how are you?
Yeah, good. I just wanted to, talk to you with respect to your work in the imaging. Can you please talk about that?
Sure. So traditionally in medicine, imaging has always been about looking at shape, looking at architecture, looking at features of shape of cells, in particular for pathology, or in radiology, looking at the shape of objects that you might see. What we are trying to do is, instead of looking at shape, look in chemistry. So try and see if we can measure spectroscopically, without using dyes, without using labels, the chemistry inherent in the tissue, and then we can use machine learning approaches to make sense of the chemistry and make diagnoses that are objective, that don't require exogenous agents, and that can be done with great accuracy.
So you mean to say the accuracy is much better in the new chemistry analysis compared to using the AI compared to the previous traditional this one, right?
Yeah, there's two aspects to it. One, there's more information, because in addition to shape, now you have chemistry information. Second, AI methods are becoming very, very robust and very good in predicting things. So if you design your AI architecture carefully, you can actually come up with results that are much better than achieved by a typical average human.
Okay, excellent. So what will happen to the current conventional technologies with respect to X-ray and CT and stuff like that? Because it is, if the chemistry and the quantum this is increasing, so what will happen to the traditional technologies?
Yeah, I think where imaging is going to go is augmented imaging. So you can think of augmentation in either the resolution, for example, so using AI to improve visibility at lower dosage with CT, for example, looking at multicolor CT, so trying to get more properties out of tissue and make it quantitative. That's the second option. The third direction I see is integration of data across scales. So you might take pathology and integrate it with radiology, something that is not pretty common now.
Correct. Yeah. So what about from the perspective of, is this already available in the field, or how much time it will take from lab to field, these kind of new advancements?
Yeah, that's a great question, because if you look at MRI or CT, it took 20, 30 years to go from the initial concepts, initial instruments, to actually being used widely across the world. But I hope that, given that we have become so used to technology in the last 10 years or so, I hope that these new technologies will make it much faster. They'll be much more accurate, because we as a society have come to expect a high performance, a high reliability, for example, from our phone. So I think we will see more reliable, more robust technologies that will come into play faster.
Okay. What about your view on the self-learning technology? Because, for example, reinforcement.
Yeah.
So how do you see that, how it is shaping up and how it is helping in the current scheme of things?
Absolutely. So this reinforcement learning idea is actually rather new for two reasons. One, the sheer capacity of data that we need to keep improving. And the improvement, of a typical case is not much after you see maybe a few hundred cases in most algorithms. But the unique, unusual cases, you actually need to see larger and larger data, and you need to have greater and greater input from the clinicians initially to correct this. So I think we'll see a growth in reinforced learned models, in equipment that can do that, but it'll require very tight integration of both data science and clinical science.
It will take some more time to go. Right. Okay. So what about, you are a veteran in cancer detection, especially the tumors use the imaging technologies. At the same time, a lot of focus and a lot of this one is going on genomics also.
That's right.
So what is your view? Is all these technologies are converging, or they are going in parallel by themselves?
I think they've gone in parallel to some extent. People who tend to focus on what has traditionally been imaging try to solve the problem with better imaging. Genomics has focused on trying to solve problems with new data, but they haven't quite integrated quite as much. So I do think what genomics offers is really exciting, that there's a molecular basis of disease and we can find it. But what we're increasingly finding that in addition to the molecular basis of disease, we need to understand the spatial behavior of the disease. And that's where imaging really comes in. So I see a small subset of useful genomic markers merging with imaging, and then using AI to make sense of it in all cases.
Excellent. And another thing which is also going on today is that, for example, using these AI, ML-based technology for detection of, lung-related diseases, using the chest X-rays and stuff like that. And that also making these doctors, though we cannot eliminate them, but is enabling. But however, each radiologist has their own views, and we put into the model, the right model is very important. What is your view? What is your thought process on that part?
I think, to me, the biggest impact of technology is in making care more humane. Actually, this is an interesting concept, because right now what we're doing is we are so overwhelmed by trying to do many things that can be automated and that don't really add value, having a really highly trained clinician doing those things. For example, entering medical records.
Correct.
That's a very simple thing from technology can handle. Or even the diagnostic technologies where you don't need to look at samples to make certain decisions. Most, I would say 80 to 90% of decisions are fairly straightforward that technology can handle pretty carefully, which allows the clinician to focus on those 10 or 20 really difficult cases that they want to see, where expertise is really required. So I think where technology is most useful is not thinking of sort of replacing the clinician type of model, but making the clinician more accessible, making their job less error prone, making it easier to deliver higher care at higher quality. Primarily, just like, remember if we used to write papers, we would type it in a typewriter, and if you made a mistake, you had to go, maybe type the whole thing again. But with, Word, Microsoft Word now, you can just, write the same document in a much shorter time. You can print it with a better printer. You can communicate it electronically. So I think technology will do the same for medicine.
So one more question I have is that with respect to the image fusion, for example, people are talking about using ultrasound and images of CT or X-ray or MR like that. How do you see, again, is it some use cases coming up for those kind of things?
Yeah, I think the difficult thing is improving use cases. So imagine taking one imaging technique to use, right? There's already enough complications. Now you take two techniques and prove them together and show that there's a benefit, widely that justifies the expense of trying to merge them together. So I think the fusion technologies at this point are primarily in the research domain. Okay. And once we start, PET-CT, of course, is a great example of a fusion technology. PET-MR is another technology that's coming up. But I think it'll take some time to show its worth. But regardless, it'll happen.
So what is your view, especially in the imaging field? What is the greatest challenge as on today?
So I think the greatest challenge in imaging is to be less inconvenient. For example, MR that is fast at low dose, CT, for example, that can be done with great detail and low dose of X-ray. That's one challenge. The second challenge is how to get more information. So could you get metabolic information? Could you get genomic information? Could you get some really high quality spatial information also? So I think these two major challenges are kind of related. And they're related by fundamental progress in theory. They're related by fundamental progress in the components that go into making imaging instruments. And finally, AI. It's a great leveler. It can really make things go a lot faster.
Thank you. And the last one is that for companies like L&T Technologies, where we are working on, helping our customers in the technology space, what is your advice or suggestion how to help our customer, especially in the imaging field?
I think it's, as a broad stroke, it's never a good bet to bet against technology. This is coming.
Correct.
And the early adopters can help shape how it comes. So I would say those who are interested, who are capable of taking this on, should participate wholeheartedly, whether it's from a critical point of view, saying I need this and this performance metric, or it's from a developmental point of view, or it's even from a testing point of view. So I think all of us are needed in different roles for this, but there's no question that this is the way it's going to happen.
Thank you, Rohit. Thank you for
so
your time.
much.
I
Thanks
really
for having me
appreciate
here.
it. Thank you.